Our cannon sadly shot 0 feet as backdraft occurred and gaseous water vapor and carbon dioxide formed within the cannon barrel, spilling out around the sides of the Nerf ball but not launching it. We attempted a second launch after taking off the osmotic pressure plate, but the absence of the plate, as well as the partial warping of the plastic from the combustion reaction, still resulted in backdraft occurring and no launch. Looking at different pros and cons of our cannon design, some pros would be that yes, a combustion reaction did occur in our cannon launch. The temperature generated in the reaction was incredibly high, which would contribute to an increased pressure associated with the reaction according to Gay-Lussac's law. Our cannon had a strong and sturdy base structure. Our angle of 45 degrees that we obtained from the virtual routine on projectile motion would have worked. Tape was used efficiently, and we were ultimately able to make the osmotic pressure plate adhere well enough to the cone structure that the air would theoretically be redirected through it. Some cons of our final cannon design include that backdraft occurred during the combustion reaction as the cannon was not airtight. The gas produced was spilling around the sides of the cone structure and was not diverted through the osmotic pressure plate. The plastic cone structure did warp during the reaction. The ignition hole was not far back enough, and the adhesive between the cone structure and the sides of the cannon barrel was not airtight enough for the air produced to be forced into the cone structure and launch the Nerf ball through the osmotic pressure plate. Lastly, the extra ring of plastic that we used to add length to the cannon barrel was not adhered tightly enough to produce an airtight seal, which contributed to the backdraft.
Our launch angle of 45 degrees was the best choice. Through our virtual routine on projectile motion, we found this to be the angle that would give us the greatest distance in firing our cannon. And if our cannon had worked properly, we assumed that this would have proved true in real life, just as it did in the virtual routine.
If we could construct a new cannon, the changes we would make would not be incredibly severe, but would be the difference makers that would allow our cannon to actually fire. We would use less adhesive on the adhering of the cannon barrel to the base, and use more of it to adhere the sides of the cone structure to the barrel of the cannon. Additionally, we might not use the osmotic pressure plate, or if we did in the new construction, we would use much less tape to adhere it to the top of the cone structure than we did in our cannon. It was an excellent idea, but with the limited supplies we had, the osmotic pressure plate was difficult to get to stay. Another change we might make is that if we were able to construct the cannon once more, we might insert the cone structure without the osmotic pressure plate on top, rather than both at once. Doing the actual cone first would allow us to be able to work with the inside of the cone as well and be able to more completely adhere it to the sides of the cannon barrel than adding the osmotic pressure plate at the end. If we were to construct a new cannon, we might make modifications like making the cone slightly smaller and moving it backwards in the cannon barrel, so you would not have to add an extra layer of plastic at the end of the cannon barrel, which was not airtight and allowed for backdraft to occur.
Overall, our group really enjoyed the Cannon project. We thought it was a fun application of skills we've learned in every subject this year from math to history, as well as fun real-world tests to see our abilities to use the material we learn and the knowledge we accumulate over the course of our education and translate that into solving a real-world problem or accomplishing a real hands-on task. It was fun to connect all of the things we learned in school to a real physical challenge and gave us a greater respect for the challenges engineers face in their field, constructing and improving things that will affect entire populations of people.
The only dislike we had about the cannon project was that our cannon didn't fire, but we think we understand why this took place and overall did enjoy it.
Overall, the Cannon project was a fun experiment where we also got to own our teamwork skills, and we can't wait to see next year's class attempt the challenge themselves.